So, okay, ladies and gentlemen, good morning to you all. And yesterday I gave you an area formula here, okay? And I want you guys to get used to this kind of picture. You can draw that here. So, one of the reasons why we did this, I'm going to say this is A, this is B, and this is C, ladies and gentlemen. Now, what you're looking at is something called an oblique what? Triangle. Okay? So I want to introduce you to an oblique triangle. Now, does anybody know from geometry what in the world is an oblique triangle? Because you're looking at it. And I'm going to put these capital letters here as well. What is an oblique triangle? Capital letters. This is going to be what? Capital B, capital A, capital C. These vertices, they are what? Oblique. This triangle is oblique. What does that mean? Do you guys remember from geometry? What does it mean? It means it's not a right triangle. So if it's not a right triangle, but yet it's still a triangle, we say this is an oblique triangle. That's just the name of it. Okay, so we're naming this situation. That's extremely important because you know where we're headed is we're headed to try to solve these triangles. We know how to solve right triangles. That's kind of like geometry, although we do have that here too. So we solve them. Where we're headed is we're going to solve oblique triangles, non-right triangles. This is not a right triangle. So the real definition of oblique is a non-right triangle. So let's write that down. A non-right triangle. Okay. And the thing about this is that it's not so easy. It's not as easy as having a right triangle. In other words, it's a little bit more sophistication. So this is kind of in some ways where trigonometry comes in. This is really trig now. Okay? And so we're gonna look at some tools to do this. Now you say, what tools do we use to solve oblique triangles? Well, we have something called, ladies and gentlemen, do you guys know what it's called? What's our first tool called? We got to learn what's called the law of what? Sines. And then we have the law of what else? Cosines. Those are the tools that we use in dealing with solving oblique triangles. So we get to study some of this stuff. All right? You guys with me on that? There's some studying to do here. There's some work to do when we solve these oblique triangles. So, law of sines and what? Law of what? Cosines. So we're going to start with the law of sines here, okay? And I'm going to prove it to you, I believe. However, I'm going to write some of this stuff down here. If you guys remember yesterday, right? So let's color it. Let's use gray. Yesterday, what did we learn? Didn't we learn an area formula for any triangle? Right? So you're going to think of these vertices. You might say, what are the vertices? The vertices here are A, B, and C. I'll use orange. A, B, C. Those are kind of the vertices. We often use those for the angles. And the others are the what? These little letters, you know what they measure? They're the distance. They're the sides here. Okay? All right, you guys okay with that? Okay, so tell me if you agree with this. If I say focus on what? Focus on A, this big A here. Isn't it true? Area is going to be 1/2. 1/2 what? If A is the angle, what are the two sides for this formula I gave you guys yesterday? Isn't it BC? Yes, it's BC. So area is going to equal 1/2 BC sine A. Is that true? And the area is also, if I focus on B now, the angle B. What were the sides? Remember what we did yesterday? We did this side angle what? Side formula for area. So if your angle is B, it's the included angle between the two sides what? A and C. So that area is going to be AC now sine B. Okay, so we're dealing with that side angle side area formula from yesterday. Okay, this is one of the reasons why we studied it. Now go to C here. Okay, side angle side. What are the two sides? Side angle what? Side. The two sides are what? A and B. Isn't C between A and B? Okay, so I want you guys to know that's AB now. So the same area will be 1/2 what? AB sine C. All right. So what do you do with these areas? Let me say this. You guys know what we do? They all represent the same what? Area. That's in gray. They all have the same area. You're going to get the same value. So what that means is all of these are equal. They're the same. They're equivalent. So let's get this out here. So 1/2 what? AB sine A is 1/2 AC sine B, which is 1/2 what? AB sine C. Okay, now with every equation, if you have a number, you have all products, okay, you're free to do what? Cancel that 1/2 from all three here. Okay. And then I'm also free, since I have equations here, right? These are all equal here. I'm also free, ladies and gentlemen, to divide both sides, even though there's three sides, by the same non-zero number. So I'm going to divide this number by, what are you going to divide that by? See if I messed up. Did I mess up? Let me double check. I think I did. So A 1/2. For A it's AC. Okay. So let me get some coffee. What do you see this here? Side angle side here? So it's AC for sine A. Okay. And what did I do for B? Did I mess up for B too? It's AC. And then for C, let's double check. C would be AB. So it looks like we're good. So this would be A what? Oops. Let's go back again. BC. Woo. Let's go to the Husky store and get some of that coffee. This is BC. I apologize. Got to wake up. Okay? Isn't BC there? Side angle side. Okay, let's double check. For B, it's AC. Okay, and for C, it's AB. Yes, so we're good now. Okay, so let's divide now by this non-zero number, ABC here. ABC here. And we get rid of this because it's gone. And then, ladies and gentlemen, we can further simplify. The C here is gone, and the B here is gone. You guys okay with that? The A is gone, the C is gone, and then the A is gone, and the B is gone. And what you are left with is, ladies and gentlemen, take a look. Here's what you're left with. Sine A over A, sine B over B, and sine C over C. Sine A over A equals sine B over B, which is sine C over what? Over C. And ladies and gentlemen, do you guys know what this is known as? You know what I just showed you guys? This is called law of what? Law of sines. So I've derived for you the law of sines. It's based on that area formula we studied yesterday. The law of what? Sines, okay? So notice this. A, B, and C, those are the sides, those little ABCs. The big A, B, and C are the angles. This is what we start to use to solve, ladies and gentlemen, what do we say? Non-right triangles. What are non-right triangles known as? Oblique. We got to use this for non-right triangles. So let's give you guys an example of the law of what? Sines. You say, why? So we can get started on our what? Homework. You got some law of sines homework. You go, wow. So, but I do have to say, for law of sines, what's going to happen is we have to take cases. The first case we're going to take for law of sines, if they ever say, hey, what's law of sines good for? Well, the first case is for a side angle side situation. A non-right triangle known as an oblique triangle that's side angle side. That's our first what case here? Okay, so let me give you guys an example here. So if they gave you here, this is going to be 52 degrees, 70 degrees, and this measures 28 meters. Okay, so notice what they did here. I'm going to change the colors, though, on you. They're going to say, ladies and gentlemen, to do what? Solve the triangle. Now, when you have side angle side, oh, I'm sorry. I apologize. Nope. I apologize, you guys. I really got to wake up. Your first case is going to be angle side angle. I apologize for you guys. This is your first case. Angle side angle. Okay. All right. So what do you guys think they mean by this angle side angle? If I said to you guys. Let's write the S better. Angle, side, angle. Okay, what do you guys think they mean for an angle, side, angle situation? What do you have? Angle, side, what? Angle. What they mean here is that the side is included. You go, what's an included side? It's just between two angles. So the side is between two adjacent angles. If you have this situation, then you always use what? Law of sines. Okay, now the first step for law of sines for angle, side, angle, the first step is always find the third angle. Remember, what does solving actually mean if they said solve the triangle? Do you guys know what solving means? What does that mean to solve a triangle? What that means is give me angle A, the missing angles, and give me the missing what? Sides. They want to find all three of these. Okay, so solving means get all the remaining values. So can anybody tell me, this is going to be always your first step. You do this first here. I'm going to get rid of the colors so they're not distracting, okay? Why am I leaving that red? Why do I leave that red? You guys know? How do I get this angle here? It's easy peasy. How do we get that? Let's write this detail. I'm going to give you guys a note here. What is the sum of the angles? Is it 180? Did you guys agree with that? Okay. So what they're saying is that angle A is plus 52 degrees plus 70 degrees is equal to what? 180. Do you guys agree with that statement here? Because the sum of the interior angles for any triangle is 180. So how do I solve for A? Do you guys know? We subtract 52 from both sides. We subtract what? 70 from both sides. Is that true? And what do we know about A? A will be what? 180 degrees minus 52 degrees minus what? 70 degrees. $180 minus 52 degrees minus 70 degrees. And what do you end up with? What is it? I don't know. Let's see. In your calculator, 180 minus 52 minus what? 70. Is that 58 degrees? Okay. So what did you just do? You just found one of the pieces of information they're looking for when you do what? Solve the triangle. So get the missing angle first, 58 degrees. That's what you always do when you have the angle side angle situation, okay? Angle side angle. That's the first case of law of sines. That's the first type of triangles you guys see. All right. Anybody have any questions on that part? All right. Now what I'm going to say to you guys is this. Now that you have that information, I'm going to get rid of the highlighting. The question's going to be, how do you use the law of sines? Notice what it says. Sine of A over little a equals sine of B over little b equals sine of C over little c. So I'm going to say, pay attention to the colors here. Notice. What do you guys have to find now? Sides. pick a side. What side do you guys want to find? Do you want to find B or do you want to find C? C, okay. Doesn't matter. So you said, Mr. Judge, I want to find that side. Okay. To find that side, ladies and gentlemen, you always use the opposite angle that you know. And you say, what? Yes. So I'm going to write down sine of what? 70 degrees over what? C. Okay, you guys see what I'm saying? This is how we use that. Isn't it true? Notice how I did this. I named that big C. So I'm using this portion in law of what? Sine. Sine of C. I made the ratio of sine of what? 70 degrees. There it is, over little c. There's your ratio. Anybody have any questions on that first step? You guys okay with that first one? Now you say, okay, what do I set that equal to? Well, use, ladies and gentlemen, an angle and opposite side that you know both values for. You have to know both values to do this. So, because I have 58 degrees and I have 28 meters, I got to use those opposite angle, opposite sides. That's A and little a. Okay, they didn't tell you this was little a, but it's little a. So I'm using this ratio. So you say sine 58 over 28. And ladies and gentlemen, there it is. So what do you guys have now? What is this called? You might say, Mr. Judge, is this why we warmed up the way we warmed up this morning? And what am I going to say? Yes. Is this why we did the S portion here this morning? Yes. What is this known as, ladies and gentlemen? This is called a what? It's a proportion. Good job. And how do you guys solve proportions? What do you think you're going to solve for? You're solving for C. Is that right? Okay. That's why we did what we did. Okay. Good morning, ladies and gentlemen. Finally get to do some work. Okay. What does that mean? Right? Isn't this going to be now what? Let's write it down. This is why we did what we did. This is what? 28 times sine of what? 70 equals little c times sine of what? 58 degrees. What are you guys going to divide both sides by now? Sine of what? That's a number, is that right? So sine of 58 degrees, you're going to divide both sides by, okay, because it's going to cancel on this side. Sine of 58 degrees, in case you guys didn't know, isn't that a number? Right? Make sure your calculators are set to degrees, ladies and gentlemen. So what does that mean side C actually equals? What does side C look like now? C is what? 28 sine 70 divided by sine of what? 58 degrees. So go to your calculator and say what? You guys ready? 28. Well, first of all, let's check. Okay. Go to the mode. Are we in degrees? What do you guys say? Aren't we in degrees here? You guys see that in the calculator? We got to be in degrees, okay? And then sure enough, we are in degrees. Okay. All right, ladies and gentlemen, you're going to do what? 28 times sine of what? 70 divided by sine of what? 58. What does that equal to the nearest tenth? What is C going to be? C is what? Anybody want to tell me what C is to the nearest tenths? 31.0. Outstanding, ladies and gentlemen. There you go. C is 31.0. Okay, you see how, make sure your calculator is in what? Degrees. And so now, if I go back here, this measures, we need an eraser still. This measures, C measures 31.0. Okay, let's get rid of all of this drama. What do you think you have to find now? What do you think you have to find now? You have to find little b. Is that true? So I'm going to repeat this here. Okay, so notice something here. To find little b, I have to use the opposite angle, which is big B, and that measures what? 52 degrees. So now I create the ratio of what? Sine 52 over little what? This is my little b here. Sine 52 over what? Little b. Do you guys see it with the colors? So that's going to be sine 52 degrees over little b. And what does that equal? Well, you guys have a choice, okay? What's your choice? Go back to the triangle. This ratio has to have two known values. The angle and the what? Side. You got to have two known angles, okay? If you don't have two known angles, you can't answer the question. So which one do you guys want to use? You got some choices here. You can use angle 70 degrees and 31. Or you can use what? 58 degrees and what? 28. Which one do you guys want to use? You have a choice because you're going to create these ratios, or a ratio. You're going to create really a proportion. So which one do you guys want to use? Green or red? Red. Okay. So sine 58 over 28. Okay. So let's go back and say, okay, what colors did we use? We use the orange ratio and the red ratio. Orange and red. And then you're going to cross what? Multiply. All right, ladies and gentlemen, here you go. 28 times what? Sine 52 degrees will equal B times sine of what? 58 degrees. Okay, cross multiplication. We got to solve for B. Is that true? Okay, so what do you do now? You have to do what? Divide both sides by sine of what? 58. Sine of what? Cancel. And you're left with what? B equals 28 sine 52 degrees over what? Sine 58 degrees. This is your B value. All right, you guys okay with that? Okay, so get out your calculator, make sure it's in degrees. If we already did it once, it should still be there. So I'm going to try to get so you can see everything, I guess, right? So we're going to put what? 28 sine what? 52. Close that. Divided by sine of what? 58. What do you end up with? 26.0. Is that true? All right. So, ladies and gentlemen, there you go. This is little b, okay? Let's get this out of the way. Little b is actually 26. So, take a real hard look at this, because congratulations, ladies and gentlemen. You have now done really your first trig equation, or not trig. You've done a this is trigonometry. You've really solved a what? An oblique triangle. And that has a lot of meaning, okay? Because geometry you can think of as solving a right triangle. Now you kicked it up because there's other triangles. There's oblique triangles, non-right triangles. And you can never use any of the information ever that's for a right triangle on a non-right triangle. This is very specific. So anytime you have a non-right triangle, what do you guys have to do? Follow, well, first case, it's going to be law of sines, law of cosines, but we just started this. There's going to be cases. This is the first case you guys use. Angle, side, what? Angle. Angle, side, what? Angle. You have to identify that first. And then what do you always do first? Since you have two angles, you can always get the what? Third angle free of charge. Quick and easy. That's what you always do what? First. So, give you guys another example. Okay, so congratulations. You just entered the world of what today? Trigonometry. And you say, oh no. I was still studying my what? My right triangles. Yo, Mr. Judge, I only started my right triangle homework. You go, well, you're behind. Is it good to be behind? It's never good to be behind. Anyway, let's try this out here. That looks too much like a what? A right triangle, but I think, yeah. No, I think I could do, yeah, there we go. Okay. And I'm going to label these vertices, which are really going to be our angles. And, you know, if this is labeled A, and this is labeled B, and this is C, okay, this is 102 degrees. Oh, I kind of messed up. Let's see. No. While I did, let me see if we can do this. Hopefully we can. And this is 12. And then maybe this is B. 7. Oops, made a mistake. Made a mistake. Oh, this is going to be 28 degrees. All right. So sometimes they'll put these lines here like this, okay? These here. What do you think they're trying to communicate? That's the angle. And then they might even do it this way here, so you guys know. They'll put a little thing here and say, what do we say? Was that 102 degrees? Okay, they'll write it that way. And what you want to always identify first is the following. What did they give you? What are you guys looking at? And you say, what do you mean? You got an angle, you got a side, and you got another angle. What is this known as? Angle, side what? Angle. And what is that? The side is between two what? Angles. Yes? What do you know where to put the A, B, and C? Well, that's a very good question. You don't. You look at the picture they gave you, and if they give you an ABC like that, okay. Now, if you said, what if they don't give me an ABC? Well, you're free to put it any way you like. Okay, you guys see what I'm saying? If it wasn't there, you can put ABC anywhere you like. It could be clockwise, counterclockwise, as long as there's 1A, 1B, 1C. Because the law of sines doesn't require A to be any particular location, or B or C. Okay, now, since you have angle, side, angle, can I ask you guys a question? What do you always do first? Always find the missing what? Angle. And that's going to be angle C. You guys okay with that? All right. How do you find that angle? It's very easy. Take 180 and subtract 102 and subtract what? 28. Okay, so you're going to subtract these here. What do you think you're going to end up getting here? What does that equal? What is that? 180 minus 102 minus 28. What does that equal, ladies and gentlemen? That's going to be what? 50 degrees here. So you found the missing what? Angle. You got 3 angles now. Alrighty. Once you have the 3 angles, what are you free to do now? Now you could use what? Law of sines. Oh my God. Law of what? Sines. Okay. So let me colorize this for you guys here. I don't remember the colors, but notice what they did here. We don't even have the letters, do we? For the sides, do we? What do I mean by that? How do I actually, if I said I want my A to be what color? Orange. Or a little green, who cares? Green. That means this side has to also be green. But what letter is it? Do you guys know? Call it little a. It's associated with, that's little a. And then the other side for B, ladies and gentlemen, you say, well, what is, if this is angle B, really angle B is right here. Okay. What side is this? That's going to be what? Little b. Now, what's this angle A here? This is going to be in what color? Isn't that green? And if I want to be consistent with colors, this is little c. Okay? Angle, side, angle. All righty. So, tell me if you guys agree with this statement by law of sines. We know sine of 50 degrees divided by what? 12. Isn't that one ratio? Notice this, though. I want you guys to notice. Why did I use that? Because I have a known angle, 50 degrees, and a known opposite side of 12. So there's my first ratio. It has to be known. Okay, so, I mean, I'll do it in, I'll do it in blue and highlight it in red. Okay, so you said, okay, you chose, why do we choose sine 50 over the 12? Why do we choose that? Because that is what? Two known values, an angle and a side. That's where you start. You set that ratio to whatever side you want to find now. What side do you guys want to find now? What's the side? What side is that? You want to find A or you want to find B? B? So you're going to have to say sine 28 degrees over what? Little b. Because you're going to create another ratio to really create a proportion. So you got sine 28 over little what? B. Easy peasy lemon squeezy. All right. Now, what does that mean, ladies and gentlemen? Cross what? Cross multiply? Okay. So I guess that means we have really what? Sine 50 degrees times b will be 12 times what? Sine of 28 degrees. Divide both sides by sine of what? 50 degrees. And what does little b become? Little b becomes 12 times sine of 28 degrees divided by sine of what? 50 degrees. Okay, so get out your TI, and what do you guys enter? 12 sine 28, close that, divided by what? Sine of 50, is that true? Okay, what do you guys end up with? Let's go to the tenths again. Good job, B is 7.4. Okay, so you're going to get 7.4. And there you go, ladies and gentlemen. You found B. You found little b. It's 7.4 right over here. How do we get A, side A now? Do you guys know? We have to use what angle? What's opposite? Do you guys see it in colors? A, green, and 102 degrees, right? So what you'll do now is you can use the same sine of 50 degrees, right? You say, what do you mean the same? We could use this already. Again, sine of 102 over A. Okay, you guys see my point? Okay, what do you guys do now with this? You're going to have to use what? Cross what? Multiply. What do you guys end up with? A what? A sine what? 50 will equal 12 sine of what? 102. Is that true? So you're going to divide both sides now by what? Sine 50. Sine 50. Do you cancel? So A will be 12 sine of what? 102 degrees over sine of what? 50 degrees. Okay. All right, ladies and gentlemen, get out your what? Calculator. Hopefully it's a TI like the one we have here. So you guys can see, 12 times sine of what? 102 divided by sine of what? 50, ladies and gentlemen. What do you guys end up with? 15 point what? 3. Welcome to the law of what? Sines. This is the first case. What's the first case? Angle, side angle. And what does that even mean to have angle, side angle? Do you guys know what that even means? What does that mean? I think that means what? Tell me what angle, side angle means, because you got to identify that. If I'm looking at my website for stuff, you got to identify that. Why do we identify it? You guys know why we identify it? Why do we identify that? What does it mean? The side is between two what? Angles. So if the side's between two angles, do you guys know what that means? What do you guys want to always do first? Find the third angle. Okay, and that's what we did in red. That's how we start, so we can use law of what? Sines. Now, a couple of things, I guess. I'm going to take a look here. This is in our textbook, and this is 6.4. We're not done with this topic. Okay? We're not done. So what I'm going to do here in the assignment, 6.4, law of sines, I'm going to do some limited kind of homework for you guys. Oh, come on. So what I'm going to share with you guys here is what I just did in Canvas under assignment portion. I started to give you guys some homework on this. Okay, I entered 6.4. I entered like 1 to 10. I don't know if you guys can see that. There you go. 1 to 10 all. So you guys can get started. Make sure you do the angle side angle. And we can do the rest tomorrow. So have a great day. Take care and stay safe. To use the law of sines to do what? What does this say, ladies and gentlemen? We're going to solve the triangle, okay? Now, this is an angle side angle situation. What does that actually mean? Right? Because you have to identify that before you start working. So, angle side angle means what? You have two angle, you have the angle side angle. That's what this means. You have two angles, and the side is between the two angles. Okay? So, ladies and gentlemen, let's take a look here. Okay? How would you begin to solve this triangle, right? Solving means you have to find every angle and every side. So what I'm going to give you guys here is time to do that. However, I'm going to get you started. What would you label if this is angle B, okay, because they gave you that vertice to get you started, what do you guys call that side? What's the name of that side? Little b. Thank you. All right, you guys okay with that? You want to name it little b. If vertice A corresponds to 38 degrees, then what do you name this side? What do you name it? Little a. You guys okay with that? All right. And if, I'll put that in red. Well, we'll put it in purple. C, angle C corresponds to what? Side C. What do you name that? This is what? 12. You guys see what I'm saying? So I want to warm up today and have you guys work on this angle side angle and give you guys some time. Approximate the lengths to the nearest what? Tenths. Good, good. Yeah, we want to try it that way. Okay. Do you guys remember here? Let's do a few things here, okay? The orange angle is called B, and that's little b. The green angle is 38, and this is little a, and then the purple angle, we do not know, and that's going to be C here, okay, which happens to be 12. All right, there's some color, a little distracting, I think, sometimes, but nevertheless, for angle, side angle, what do you always do first? I mean always, not sometimes. You find the missing angle. Is that right? Thank you. We find angle C. And how do you get angle C? You take what? 180, and you subtract all the what? The other two. Okay? What do you end up getting when you do that? Let's get out our calculator. Say good morning, TI. Okay, remember that's always the first thing that you do here with this. $180 minus 38 minus 28, and you get 114 degrees. And I guess the color this morning here for that was actually what? Purple. So, ladies and gentlemen, this is angle what? Angle C. So this is what you guys want to do, 114 degrees here. Okay, you guys okay with that? That's the first one you found. Okay, now, what do you guys do now? Do you guys know? You go straight to what? Law of sines, okay? Sine of A over little a is sine of B over what? Little b, which is sine C over little c. So A was green. Okay. Gold or orange was B, and then purple was what? C. So, ladies and gentlemen, take a look here. All right. Now, tell me, what letter did you guys want to solve for first? Which one? B. Okay. So, if you want to do that, remember, what do you start with, though? You can only solve a proportion if you know 3 values out of the 4. So you need 3 values out of the 4, right? 3 things have to be known. So what do you guys know? What are you guys going to use? I would say pay attention to what? Well, pay attention to the fact that you know angle C and you know what? The opposite side. There's 2 values there. So start with the 2 values and you say, okay, sine of 114 degrees divided by what? 12. So you start with the 2 known values. And then now you can set that equal to any ratio that has a missing value, like you said B, right? So for B, though, what's the corresponding angle for B? What's the opposite angle? You guys are looking at it. It's what? 28. So you're going to say sine of 28 over what? Over that little b. Now, if you said to me, no, I want to actually find A. Maybe you said you'd rather find A. What would you do now? If you were a person who would rather find side A, you start again, ladies and gentlemen, with the 2 known values, right? And then now you have to look at what? The A. You're going to put that over A. But you have to know what angle is associated with A then. What is opposite A? 38. Yeah. Okay, so that'd be 38 degrees. You guys okay with that? What's that? Well, be careful with what you said. Say it again.
Can it also be like sine 38 over A equals sine 1 over?
Yes, you could left side equals right side equals left side. Remember this saying here. Jennifer Lopez is who? J-Lo. Or we can say J-Lo is Jennifer Lopez. Yes, you could do that too. Now, absolutely. Okay, so ladies and gentlemen, like we warmed up yesterday with the S, what did we do? Right? What do we do? Cross multiply. So now, ladies and gentlemen, here's the story. B sine 114 degrees becomes 12 sine what? 28 degrees. Divide both sides now by what? Sine 114 degrees. Now B will be 12 times what? Sine 28 over sine of what? 114. Let's see what B is going to be approximately. Okay? $12 sine of what? 28 divided by sine of 114 degrees. Ladies and gentlemen, what do you guys get? What is this B going to be? This is 6.2, ladies and gentlemen. What do you guys think? What do you guys think? Wow. And that, what color was B? Orange. Okay. So this is what we're looking for. Wasn't this based on the ratios we worked on yesterday? Right? 6.2? All right. You guys go with me on that one? You got that. All right. We're almost there. What do we need to do now? What's the other one? A. Okay. So for A, I think we still have it. Yeah. A sine 114 becomes 12 sine of what? 38. Okay, you guys ready for this now? You guys have your calculator set to degrees? Okay, let's try this. I'm going to clear this out now. I'm going to say what? Go to the TI. We're going to say what? 12 sine of what? 38. Close that. Divided by sine of 114. Close that. 8.1. Is that true? And that's going to be what? Green. Okay, so, all right, green. 8.1. There you guys go. And then that's that. You guys have solved your what? You guys have solved your triangle. Easy peasy lemon what? Lemon squeezy. Yay or nay? Okay, now, here's what I want to remind you guys, or here's not what I want to remind you, but here's a second situation that you use law of sines with. Okay, so I'm going to try to double check this here. This is what we're going to have to spend some time with. Side angle. So here you have some concern. Okay, this is the side angle case. Because we have cases here, ladies and gentlemen. So in the case of side angle, and we have to solve a triangle. So I need to get here something. So here is an example. So if they gave us 35 degrees, 5, and maybe 8. And this is units here, okay? They could give you 5 inches, 8 inches, right? It could be in feet. It's just units of length. Now, I'm going to do this here. Now, remember what I said to you guys. You said, Mr. Judge, I don't see any A, B's, and C's. Okay, you don't have to be given A, B, and C, but if you're not, I would say to you guys, you should do what? You name them yourself. So here's maybe A, and here's B. Now here's C. Okay. And why do you guys think this is called side angle? Let me go through this phrase, and it's technically known as side angle, meaning you have side angle. I apologize. Let me go back here. Well, we could do that side angle. I apologize. I need to give you side angle. Is that right? I apologize. So let's give you 2 sides. I got to give you side angle. So if I say here, we need another angle here. Let me do this. Let me erase that. Let's be consistent. 35 degrees. Apologize to that. And now I'm going to say this will be 25 degrees. Okay. This is a side angle situation. I apologize. We got to wake up. Where's my coffee? Let me go get it. Yeah, I know. I have. Okay. Now, why do you think they call this side angle? You have a side. There you go. And then I have 2 adjacent angles, okay? So this means they're next to each other, the AA. These angles are adjacent to one another. All right. Okay. Okay, you guys okay with that? And again, we have to solve the triangle, so we have to get all these values. Now, okay, so if I say to you, hey, if this is vertice A, and there's your angle A, what do you call this here, ladies and gentlemen? Little a. Thank you. Is that pretty good? And I'm going to keep the B blue. Vertice B, angle B. And then I'm going to say what here? This will be what? Vertice C, angle C. And this will be little what? C. Okay, because we're going to be using law of sines here. Now again, if you have two angles, that is very nice. Why is that nice if you have two angles? What's that? You can find the third angle. How do you guys always find the third angle? Take 180 and subtract the other angles in your triangle because the sum should always be 180. Is that true? Do you guys remember that statement? Okay. $180 minus what? 35 minus what? 25. And what do you get? 120. So ladies and gentlemen, this measures what? 120 degrees. So we found that angle. Okay, now we're home free. You say, why are we home free? Because we could now use what? What is this known as again? Law of sines. I know it has different colors, but we're going to change the colors. Okay, so remember, when you use law of sines, this is what this is. You have to start with a angle that's known and a side that's known. So can you see in this triangle, where do you have a known angle and a known side? B, is that right? So we're going to write down sine of 25 degrees divided by what? 5 will equal, because this is B. B. Angle is known and side is known. Is that true? Okay, now I can say, let's look at A. So that'll be sine 35 over A. So I can say this equals sine 35 degrees over what? A. Now, I could have said, I want to find B instead. Well, I'm just going to set up the proportions now. And let's focus on this portion here is the A in green. Okay. And let's now focus on C now, because what does that mean in orange? Sine 120 over what? C. Bless you. So we're going to have to now, bless you, cross multiply. Is that right? So you get what? A sine 25 degrees becomes what? 5 sine of what? 35 degrees. Divide both sides now by sine of what? 25. A is 5 sine of what? 35 degrees over sine of what? 25 degrees. So let's find what A is. Okay, let's get out our calculator. Let's find A. So A is going to be, ladies and gentlemen, 5 sine of 35, close that, divided by sine of what? 25. What do you guys end up with here? 6 point what? And then that's green. Okay. That's 6.8. So this is going to be little a. 6.8. We're almost there. C sine what? 25 becomes 5 sine of what? 120. Divide both sides now by sine 25 degrees. C will be 5 sine 120 divided by sine 25. Okay, so let's get out the triangle here, right? Let's get out our calculator. Clear that out. So 5 sine of 120 divided by sine of what? 25. Let's close that up. And ladies and gentlemen, you get what? 10.2. All right, 10.2. And that's gold, I guess. That side C, it's 10.2. What is that? No, you got it's very specific. You got to use these exact numbers, or there are no other options. So this is going to be a side angle what? Angle situation. Okay, you guys okay with that one? What do you think? Is that easy peasy? Side angle angle. So let's give you guys one to try. Okay, we're going to have you guys try one. $70. 10 units. 10 units. Now say here's A, here's B, here's C. Okay? You're going to solve this what? Triangle. So let me say again, how do you know what kind of triangle this is? How do you guys know? What are you guys looking at? Angle. And then they gave you two what? Sides. Is that right? So they gave you what? What do they call this? Side what? Oops. Sorry. I think I'm making another one. We want to give you, I'm really, it looks like I want to give you this. What do I want to give you? Side angle. I want to give you two angles. So, So let's do something like this. Um, 60 degrees. Now we're in business, okay? I want to test you on the ones we just did. So what did they give us? All right, what is this known? Is this what is it? Is this a side angle situation? How do we know? Yeah. Let's do that again. They gave you a what? Side with two adjacent angles. Okay. They give you a side with two adjacent angles. Now, you can try to solve this. Find the values. Okay, find all the other values. All right, you guys ready for this? Did you guys get some answers? Okay, so here's what I want to share with you guys here, okay? I don't know what colors we're using. Let's do this. For angle B, we'll use orange. I think I like using blue. For angle C, you might say, wait a minute, you forgot. Isn't this little c, little a, little b? It is, right? And then I guess that leaves us with A, I guess, right? So we'll use green. Okay. So going back to law of sines, okay, ladies and gentlemen, let's see if we are good. So B was orange. Green now is A. And then blue. Okay. So remember, which color or which angle do you have the adjacent what? I'm sorry, the opposite information. Is it green? You have opposite known. You need known values. So which color has the two known values? It has to be known. Orange. So you say, what do you mean? Well, 60 degrees and the opposite side is 10. That's where you start. So sine 60 over what? 10. And then that will equal, now we can do this. Sine 70 over what? C. And I apologize. I went out of order. I apologize. What should we have done? Can we find A? So 180 minus 60 minus 70. What is A? We forgot to do that first. It's okay, though. We could do that now. Is that 50 degrees? Okay. So we also have good information here. Okay? So you might say, why is that good? Because in green, we have one known value, and that's going to be enough to find A. Because we can say now, sine 60, okay, over 10. That first ratio will equal what? Sine 50 over A. Cross what? Multiply. Okay, so when you cross multiply, you get what? C sine 60 is 10 sine what? 70. Divide both sides by sine 60. Ten. Sine 70 over sine of what? 60. Okay, ladies and gentlemen, here you go. We have what? 10 sine what? 70 divided by sine of 60. What do you guys end up with? 10 point what? 10.9. And I guess that color is, what do we just find? C, right? So C is blue. And there you go. Oops, you guys can't see that. Okay, there we go. We just put here C, 10.9, okay? So 10.9 goes up here. So now we have to find A now, right? So we have the other ratio to find A. This is the work we did. A sine 60 becomes what? 10 sine what? 50. So now you're going to divide both sides now by what? Sine of what? 60. Ten sine 50 over sine 60. Right? You guys okay with that? Okay, so let's clear this out. Let's get out the TI. And now it's going to be what? 10 sine 50 divided by sine of what? 60. 8 point what? 8.8. Is that true? Okay, so this is going to be what color? Green. This would be 8.8. All right, ladies and gentlemen, I'm just going to highlight this for you guys, and there is yet the second case, which is side angle angle. Okay, anybody have any questions on that? Was this kind of the stuff we worked on yesterday with those ratios? Okay, because we're going to have another case, what's called side-side angle. Now, both of these situations here that we already dealt with, okay? So if we recall, we dealt with what? Side angle angle. What I'm saying is there's two angles here, and you always get the third angle first. So you're in a good situation, right? Law of sines. It's great whenever you have what? Two angles, because now you could get the third. What was the first case we looked at? Angle side angle. We looked at this yesterday. Again, you have two what? Angles, and you could get the third angle. All right, you guys, that's an important detail. However, now you might say, hey, Mr. Judge, what's going on now with this stuff? Well, you have some concern. You say, what's the concern? There's only one angle. So when you have the side-side angle situation, ladies and gentlemen, I want you guys to note something here, okay? There's going to be three cases. Okay, you don't see that yet, but you will. There's going to be three cases, okay? Let's note. And now say, okay, case 1 is known as having one solution. Case 2 is when you have two what? Solutions. And then case 3, you have what? No what? Solutions. One solution, two solutions, and then no solutions. Side-side angle. Okay, so this is actually going to take some time, in all honesty, to go through all of these three cases. And that's what they're called, 3 cases. But what I'm going to work on first today with you guys is showing you the one solution case, okay? Cases where there's one solution. So let's go through that, and you guys can see my point. Say this is 48 degrees. And this will be 10. And this is 14. Of course, the units. Vertex A. Vertex B. And vertex C. Now, let's verify what we have, right? We have what? Side, side, 2 adjacent sides, right? So when you see side, side, that's what they mean. You got adjacent sides. And adjacent means what again? Next to. So you got 2 sides next to each other. So it's side, side. They are adjacent, and then you're followed by a known what? Angle. So this is the case. This is side, side angle. So when you have side, side angle, ladies and gentlemen, you're already aware that, okay, this is where I might see certain things here. I can see either of this. I can see either one solution, 2 solutions, or no solutions. So this one's going to involve us to have some study, of all these cases, really. Okay, let's investigate. Let's see how this works, right? So you guys can see 2 adjacent sides followed by an angle. So we're going to use law of sines, okay? So let's get out some colors again. Do the colors help you see everything? Okay, so what do you guys know here? 48 degrees and what? 14. You know what I'm going to do? I'm going to say this. I know sine 48 degrees over 14 involves 2 what? 2 known quantities. I know the angle and I know the side because that side opposite is called little a. Is that true? You guys with me on that? So I already know that when I see that. Oh, okay. And then, ladies and gentlemen, you kind of have a problem here, right? This is the problem when you only have one angle. If I go to orange and I say, could you guys tell me? This is vertex B. This is angle B. And then this is side what? B. So you say, I can say sine B over what? 10. And then you might say, I have a bigger concern. What's your bigger concern? Vertices C, ladies and gentlemen, right over here. And what? I have a missing angle. And I also have a missing what? Side. You guys okay with that? So if you said, I want to start everything like we've been doing, to say this is sine of what? 48 degrees over what? 14. And this is going to be sine C over little c. So you're going to say, okay, I'm going to start with what is known. All right. Cross what? Multiply. So we're going to get what? 10 sine 48 degrees will be 14 sine B. Is that true? Okay, so here's what we're going to have to do, ladies and gentlemen. You see that there? Okay, what is that? That's sine B. You're going to have to solve for this. This is a different equation. So you're going to have to now divide by what in here? How do you solve for sine B? You divide by 14, both sides. Gone, gone. And now we can write what? Sine of B is 10 sine 48 degrees over what? 14. Okay, you guys okay with that? Okay, now I'm going to recommend you guys do something here. Okay, I'm going to recommend compute that value. Use your calculator here, okay? So you might say, what do you mean, use the calculator? Use the calculator here. In your calculator, and in your calculator, go to the nearest thousandths. Where's the thousandths position? Yeah. Let's see. You guys know, is that 3 decimal places? So let's try this out. You're going to say what? 10 sine of what? 48 divided by 14. What do you guys end up with? 0. What? 0.53 what? 1. Okay? Now. Alrighty. So what we're going to now do here, 0.531. The question's going to be now for us, ladies and gentlemen, okay? What is angle B? This is an angle. Now, this is going to go into, we're going to study, I should say to you guys, we're going to study a few things in our future. But bless you. But the book is going to start us the book starts us now with this. So what I'm going to say to you guys is this. You can solve for angle B by taking the inverse sine. Yeah, inverse sine of point what? 531, okay? So this is called, I want you guys to take a look at that. We can get B by using the inverse sine key. Inverse sine function. But it's a key on the keyboard for your calculator. Okay, and that's not a reciprocal, that's an inverse. It's an inverse function. We'll be studying inverse functions in our future, right? We'll study those. But for now, that's coming in our future. We can actually punch this in our calculator. All right, so just wanted to let you guys know, for now, we punch it in. So let me share with you guys where to find that, okay? And you go, well, where do I find that inverse key? Scroll in. Okay, do you guys know where sine is? You see the sine key? Inverse sine is in blue. You say it's in blue? Yes, inverse sine is in blue. So what we're going to have to do now is we're going to do this. We're going to take the second sine key in blue and put 0.531. And what do you guys end up with? What does that equal? 32.1 degrees. Now, what I'll say to you guys, just go to the whole degree, okay? What do I mean by whole degree? Do you guys know? That's a nice whole number. So B is going to equal 32 degrees. Okay, you guys okay with that? So you say, okay, B is 32. But then that means a few things here. This will be what? 32 degrees. Could you guys tell me what angle C might be? 180 minus what? 48 minus what? 32. Okay. So let's find out what that is. 180 minus what? 48 minus 32. What do you guys get? 100 degrees. So this equals 100 degrees. You now have three angles. Is that right? Okay. So this is what you guys get to do. And so what did you just find here? You found angle C, 100 degrees. Okay? Could you now, ladies and gentlemen, find little c now? Yes. So now, if we cross multiply, you get what? Here's what you guys get. You're going to get what? C sine 48 degrees will be what? 14 sine 100. So you divide both sides now, ladies and gentlemen, by sine 48. And this is how you guys get little c. So ladies and gentlemen, you're going to say now 14 what? Sine of 100 divided by sine of what? 48. Okay? And you get now 18 point what? 18.6. What color was C? I think that was in purple, right? So we get 18.6. Let's color it purple. You guys can't see that, but okay. 18.6. So go back here, and you have now found everything you need to find. 18.6. Okay, now, you might say, this is a solution. And I want you to give you guys a disclaimer here. Here's the disclaimer. I'm going to put it in red. There may be a second solution. This is my disclaimer. And we're going to have to investigate that in our what? Future. There's more to the story. So stay what? Stay tuned. You might say, why might they be, ladies and gentlemen, a second what? Solution. This is going to be a big deal for us in the future here, okay? Because you may have two triangles here as opposed to one. So you do need more information about that. That's the truth. And we will study that because that's part of the course. So ladies and gentlemen, I hope you enjoyed Law of Signs this morning. And please make sure you get to your what? Homework. When? Oh, yesterday. You guys know what I mean? All right. Take care. Stay safe. Have a wonderful weekend. Going. Here we go. Okay. All right. Getting to the textbook here. And okay, ladies and gentlemen. Okay. So here's kind of where we left off, ladies and gentlemen. I want to share with you guys, what do we say here about this situation here, right? This here, when you have side angle, and you have to use law of signs, okay? Side angle, that's two adjacent sides and then an angle, right? That's why SSA, okay? So these are two, just to go back and remind people, because this is an important thing. The SS is two adjacent sides. Sides that are next to each other and an angle. So to recap, what we were saying is, when you have this situation, you can have one solution, two solutions, or what? No solutions. And so we went about solving, for this because we were given side angle. And then now, ladies and gentlemen, we're done with the solution. But then, what do we say? We went through this whole process. We said there may be a second solution. So once you find one, there may be what? Another, okay? Now, the question here is a big what? Why? So why may they be another? Well, let me say to you guys here, we're going to have to go out and consider two things. Consider the graph of sine. Now, we're going to look at graphing, okay, in great detail after test 2. So I usually have it before test 2. This time I decided to put it after. So, we're going to look at a lot of that detail. And so let me draw a picture for you guys so that you guys know that, if we consider the circular function, right, for sine, okay? What was the circular function for sine? You guys remember? Sine of any angle, even if the angle is in radian measure, was that the x or y coordinate value? That's the y coordinate value. Is that true? Okay. So that's the y coordinate value. Now, our s here, if you guys remember, this is arc length. So s can be, we're going to consider that angle s to be 0 and what? 2 pi values. So go back to algebra, and you say algebra, yeah, go back to algebra, and let that the s value be an x value. So what you have now is this function, y is sine of what? X. This is now called the sine function. Yeah. Yeah, go ahead and close that. Well, let's let the gentleman in. Yeah, there's like a negative pressure I hear in the building. Okay, I don't know how they get rid of it, but evidently there's a negative pressure. So you get to hear it, you get to feel it, and the doors open pretty tough. It's hard. It's a whole thing. So somebody should fix that negative pressure. But anyway, negative pressure. It sounds like Halloween outside. Is that right? Yeah. Kind of sounds like it. So anyway. So here's what we're saying. If I replace what? These values. Now, remember, pi is about 3.1. Okay, 3.1. And there's a couple of ways I could go about this for you guys, okay? To say to you guys that, okay, let's go here, numerically speaking. Okay, numerically speaking, this domain that we're looking at, remember, pi is about 3.1, so that's about 6.2. Okay? Pi is 3.1. Numerically, we're looking at this in terms of those numerical values. So this would be a 6.2 for you guys. This is your sine function where the domain is restricted. Domain, if you guys remember from intermediate algebra, these are the x values now. And so what does that mean? Well, if I go to Desmos, I think I still have it. There we go. I use that for my, classes here, other math classes. You guys will see the sine function here. Okay? Now I'm going to restrict the domain from 0 to 2 pi. And I think, yeah, there we go. 0 less than or equal to x, less than or equal to 2. Now I think this does have pi, where I think I have to spell it out. Okay. So there we go. There's a nice picture of what? Sine, if you will. Okay? And I'm going to try to sneak this picture in if I can. Just to go over the details that we care about, we're going to, like I said, we're going to be graphing this curve extensively after test what? 2. So add to existing no law of sines. There we go. There it is. So I'm going to move all of this down because it does not like being on a crease. Okay. So we're going to sidetrack a little bit here. Give you guys some real detail here. Okay, so remember, this comes from that unit circle. Where's our all students take calculus? Okay, so remember, we're talking about these terminal points here, right? Goes from 0 to 2 pi, all right? So I brought this in for a reason. So if you plot these points for x on the unit circle, which is really the arc length s, so we get the y coordinates, we can now put this on a Cartesian coordinate system where this is your x and y axis. Here's your x axis, okay? Here's the y-axis. So you have really your x between 0 and 6.2, which is 2 pi, and y is going to be, oops, let's go back here. Your y coordinates are going to be between, ladies and gentlemen, +1 and -1. So you're really looking at these, you know, these values here. And they all come from that unit circle now. So if you're a terminal point, right, I know you have the x and y coordinate here. Well, the x coordinate was the s value, right? That's what we're saying. We're going to replace that value with, you know, with an x value. And we're going to plot it on the Cartesian coordinate system, which is what you did, all these points. Now, there's some very, very special points I want to point out to you with the sine curve. So in our future, we're going to be looking at graphs of sine. Not today. But this is where these points are very special on the curve. Let's go look at the geometry of the curve, right? 0, this is where pi is. And that value here of x is 2 pi. Okay, these are the intercepts, so you guys know. Wherever you cross the x-axis, you're on an intercept. So just kind of let you guys know, we care about that detail. We're going to revisit this in our future. Those are called x-intercepts. So they happen at 0, pi, 2 pi. And then we have these special locations on the curve. Okay, that's kind of a special location. This is where x is pi over 2. And why do you think this is a very special location, this point, ladies and gentlemen? Why do you guys think that point would be special for the sine curve? Well, because if you're standing here, you're standing on a what? This is where you have a maximum value, a maximum altitude, okay, of 1. So that's the maximum value for sine here, okay? So it has that value of 1. That's the maximum value for sine. And then over here, we will say you guys have another special location if you're standing over here. Okay. That's going to be where you have a minimum value for sine. And that actually happens at 3 pi over 2. So at 3 pi over 2, ladies and gentlemen, you're at a minimum value, which is going to be -1. And this is why we say the y-coordinates are between -1 and +1, while the x-coordinates are between 0 and 6.2. This is called one cycle of sine, and again, we're going to revisit this. Okay, so I just want to kind of share with you guys a little bit of the detail. Now I'm going to go to some more colors here, because you might say, what does this have to do with all students take calculus? Well, any angle, let's pick a color, and I think I've used purple. Any angle between 0 and pi over 2. All right? What quadrant does that represent if you're an angle between 0 and pi over 2? Go back over here. What angle is between 0 and pi over 2? What quadrant does that represent? Isn't that quadrant 1? Okay, so I want you guys to really make that association because that's really what's going on. So any angle between 0 and pi over 2, we're really talking about, that's 90 degrees. Is that true? So that's quadrant 1. All right, you guys okay with that? Anybody have any questions on that? And if I said to you in green, right, between pi over 2 and what? Pi, what quadrant are you in now between 90 and 180? Right? So what quadrant is between pi over 2 and pi? What do you guys think? Well, between 90 and 180, isn't that quadrant 2 here? Right? You guys okay with that? So quadrant 2 is represented even. So what do you think if I said to you any angle between 180 and what? And 270? What angle is between 180 and 270? That's what? Quadrant what? 3. Okay, and then finally, maybe we should pick another color. Between 270 and 360, right? What angle does that represent? Do you guys know? That's quadrant what? It's quadrant 4, is that true? So, ladies and gentlemen, I want you to compare and contrast here that when you started this whole idea, right, we do have the angle theta on that unit circle. It has an associated arc length. The circular function for sine graphed in the Cartesian coordinate system, every xy point can be graphed here like it was from algebra. What you guys are looking at is some extremely important, useful information. This is quadrant 1. This is quadrant 2. This is quadrant 3. And then this is quadrant what? 4, okay? So let you guys kind of drink that in because we have certain situations here, right? Okay, you guys okay with that? Side what? Angle. Okay, you might say, what does this have to do with what we're talking about? Well, ladies and gentlemen, side angle is called the ambiguous case. This is the case you look out for law of sines, the ambiguous case. You say, why is it ambiguous? Because you can have either what? One solution, two solutions, or no solutions. This was the example we already did. Now, let me share with you guys what you have to do now, okay? Because you know, if you have one solution, well, there's a solution. You did it already. That was on Thursday. You solved it. So this may have another solution. And then you go, well, how do I know? Well, what was the angle? If you guys remember, I think what was given, do we have to go back? You guys remember? 100, well, let's go back and think, right? 180 minus what? 48 minus 32 gave us 100 degrees. Is that right? Let's go back. Isn't that the original question? Okay, well. All right. Well, first we had to get the 32. Oh, I see what we did first. You have to go back to this step here. Okay. That was angle B. This is what we got first. Okay, so what I'm going to do here is this. I'm going to copy this. And we're going to write down, hopefully we're going to remember what we had originally. Let's go back. We're going to do that example. Okay, so we didn't have this. And I guess we didn't have what? This. Okay. Oh, and this is what we're given. So this is our situation, right? You guys with me on that? So this was the given problem. I'm going to call this now B1, which is equal to what? 32 degrees. Okay, because that was the first angle we got. This is in black, everything in black. This is side, side angle. You had a side, you have a side, and this was that angle next to a side. We found 32 degrees. We call that B1 because B2, let's see if you guys can think about this, right? Okay, I'll go over another one in detail. However, where do we get the B? Remember we found B? There we go. Let's go back up here. This is the information that we did. Sine B is this value, and we found what B is. Okay, so let me go back and copy that too, and bring it down. So we're back to the story. You go, okay. Sine of B is 0.531. And we found B to be 32 degrees. Is that true? Okay. So we're going to call that now B1 here. Now you might say, okay, that's B1. We got that. Let's bring in that sine curve now and share with you guys what I'm talking about. Where's our sine curve? Should be here. So I'm going to go out. I'm going to erase all this color. .32 degrees. What quadrant is 32 degrees in, by the way? Do you guys know? Yeah, 32 degrees lives where? Let's get rid of all this other detail. Okay, 32 degrees. To share with you guys what's going on. Remember, sine of B is 0.53. Is that right? So 0.5 is really halfway. This is where that 0.532 would be. 3.1. Okay. So I'm going to draw a line here, and this is that first solution. This is where it's 32 degrees. So what I'd like to say to you guys is there's a second solution here. So this is your angle B that you found to be 32 degrees for that first triangle. So the question is, what is the other angle if it's 32 degrees here, right? Your other solution will be in quadrant 2. There's two solutions for sine equal to that 0.532. So if I go back here to really emphasize what's going on, right? 32 degrees, you have this angle here. Okay? That angle measures 32 degrees. But you have a quadrant 2 solution as well. And you might say, well, what's the quadrant 2 solution, right? So if this measures 32 degrees, we have B1 here. What would B2 have to measure then? What do you guys think? How do you find that angle B2? This is your reference angle here. So how would you find that other angle? Yeah. So here's what you guys always do. You say, what? Always? You guys like always. B2 will always be 180 minus what? 32. Okay? Always, always what? Always. So you have to find, what is 180 minus 32? What does that equal? 140 what? 148 degrees. Okay, let's go. Where are you, TI? You should be on the... I think the TI is there. Yeah, 148. Okay. So you guys go. Here's the second what? Here's the second angle, B2. So if you go back now and you say, okay, this now measures what? This is the other B angle. It's 142 degrees is the other B. So this is what you're going to always do to find the second B angle. 180 minus B1. So I'm going to put that in the notes. However, where did it go? Oh, I guess we're putting it here. Let's go back. Let's put it over here as well. Well, this was 32. Okay, that was the first B1 we got. The second B1 is 142. This is where it was at. So you have the second angle. So once you have two angles, aren't you guys happy? You say, I'm happy because I'm trying to solve the triangle. How can I get this angle? Do you guys know? What do you do to get C? So if B1 is 32, let me give you guys a fact here now. B2 is 180 minus what? B1. Always. It's the supplement. So how do I get angle C now? From side-side angle. We did our homework over the weekend? Okay, so how do we get that? What do? We say what? How do we always get a third angle? 180 minus what? 48 minus what? 142. Do you guys know what that is? What is that? Let's ask the TI. 180 minus what? 48 minus what? 142. What does that equal? Negative 10 degrees. Is that right? So that equals negative 10 degrees. Now, what do you guys know about this? Let's ask you. What do you guys know about that angle? It can't be negative. Outstanding. So what does that actually mean since we actually went through the steps? What does that mean about that solution? Well, it doesn't make sense. It doesn't make sense. So the second triangle that we got, by looking at where sine is equal to 0.531, right in here, the second angle being 42 degrees over here, right? Oops. Come on, cooperate, iPad. 142 degree angle, that does not make sense for us. That means there's only one what? Solution, ladies and gentlemen. So remember, in the ambiguous case, SSA, side-side angle, what do we say? You can have one solution, two solutions, or no solutions, and this is a case where they have what? One solution only. That's it. So you just check the second triangle to see if it makes any what? Sense. If it doesn't make sense, you throw it out. If it does make sense, well, there's going to be two triangles that satisfy the criteria. So for the ambiguous case, this is a very, very famous side-side angle known as the ambiguous case. In any trig book you guys look up, you're going to have either one of these situations. So I'm going to go through these examples for you guys this morning. The ambiguous case does have more work because you can have possibly two triangles or even none. So side-side angle, the what? The ambiguous case. It's a very, very famous ambiguous case for law of sines. So, okay. That's a one solution. All righty. Now, let me show you guys a picture of a triangle that may have two solutions here. Okay. Let's see. going to say 43 degrees here. This is 250 units. And this would be 186 units. And call this vertice A, vertice B, and vertice C. So you might say, why do they call this side-side angle? Do you guys know why they call it side-side angle? Because what are you given? Two adjacent sides. They're next to each other. And then you have a what? Angle. It doesn't matter if it's counterclockwise or clockwise. Okay? Okay, you guys okay with that? Two adjacent sides followed by an angle. Side-side angle. Okay. So, all right. What do you think your first step will always be? Do you guys know? Label the sides. So this will be little a, this will be little b, and this will be little c. Do you guys agree with that? Do you guys see my point? Okay. All of the sides opposite the vertice use that letter. All right, now for law of sines, what should you guys always use? You always have to start with what? The angle and the opposite side. Those have to be known. So because we have 43 degrees and 186, you start always with what? Sine 43 degrees over 186 units. And what does that equal? Right? You're going to have to now use, ladies and gentlemen, the angle with a known side. So this is going to be little b. So we have now sine of an unknown angle we call b over 250. And now we can solve this because we have 3 known values out of 4. Okay, so this is your first step that you guys, do for the ambiguous case always. Okay, you're going to try to solve for the unknown angle b here. Okay, easy peasy. You guys want to take a look at that? So, multiply both sides by 250. Aren't you going to end up with sine b going to equal what? 250 times sine of what? 43 degrees divided by 186. So in our TI calculator, 250 times sine of what? 43 degrees divided by 186. Okay, and what do you guys end up here with? What's this number? Do you guys know what that number is? Yeah. 0. What? Go out to 3 decimal places. 0.191 what? 7, okay? So here's what we found. Sine B is going to be 0.917 here. Okay, so I'm going to highlight this because we're at a special place. So I'm going to go back to my sine curve because I'm going to give you every gory detail. Okay, so let's see what this means here. Okay. Sine B isn't where's this point 917? Isn't that almost 1? You guys see? So draw this line here, this horizontal line, because that's where the sine curve is 0.917. It's almost 1. And again, we're going to find that angle. This angle is going to be what? B1. And this angle is going to be what? B2. Where sine of B equals 0.917. What do you guys want to use at this point, right? At this point, you have to find what B is. So B is the inverse sine of 0.917 in your calculator. This is what this tells me. B will be the inverse sine of this. And then let's find what that actually is. Okay, you guys with me on that? That's kind of what we know automatically. So in our TI, you say, okay, TI, I hope you're in degrees. You could check the mode, and sure enough, you are in degrees. Okay. So inverse sine, we got to go second sine, because it's in blue. Do you guys see that there? Okay, now enter the numbers. 0.917, close that out. What do you guys get for B? Go to the nearest whole number for the angle. What is this answer? What do you guys think? What do you get? What's B1? 66 point what? Well, to the nearest whole number, it's just 66 what? Degrees. Is that true? Look at the decimal. The digit to the right's a 4. So we're only going to go to we're going to make that kind of simple. And I call this now B1. But that's our first angle here, 66 degrees. This is what we have now. Okay, you guys with me on that? So let's see. The second triangle, ladies and gentlemen. How do we get B2 then? What's B2 will be? It's 180 minus that what? 66 degrees. So it's the supplement. And we say 180 minus 66. If I can, what happened? I don't know what I did, but. Uh-oh. TI plus. Okay. Oh, I guess it's up here. Okay, so we're going to do 180 minus what? 180 minus 66 degrees. What's that going to be? That's 100 and what? 114 degrees, ladies and gentlemen. If I go to the iPad here. So this would be 100 and what? 14. We're going to put that 114 here. And I'm going to call this the what? The second what? Triangle. So go back now, ladies and gentlemen, to the first triangle here. Okay? So how do I get angle C in the first triangle? If I have two known angles, 180 minus 43 minus 66 degrees, what do you guys end up with? 1 what? 80 minus 43 minus what? 66. What do you guys get? 71 degrees. Is that true? Bless you. So we got that angle. That's 71 degrees here. Okay, that makes sense. Yes.
Why 66 instead of 6.5?
We're going to the whole number. We're just making it easier. We could go to the tenths. We could go to the hundredths. We could go to the thousands. I just think to try to illustrate it, we'll just go to the whole number. What about this next one? How do we get that C angle here? Do you guys know? How do we get C? The same way. What do you take? 180 minus what? 43 minus 100 and what? 14 degrees. Anyway. So we're going to go to the TI calculator. Okay, we're going to take what? 180 minus 43 minus what? 114. What do we get here? This is 23 degrees, right? So this is going to be 23, which means we just found C, which is 23 degrees. Okay. And that makes sense. Does that make sense? As long as you don't have a negative angle, guess what? You're going to have two solutions, ladies and gentlemen. All right? You got two solutions here. What do you think? That's what's going on. So I'm going to go back to the first triangle here. Okay? And I'm going to erase. I'm going to have to find now. I'm almost done. How do I find this little C now? Right? Do you guys know? I have a known what? Angle and an unknown side. So I'm going to erase this because we've used it. We create the ratio now. Sine of 71 degrees over little c, ladies and gentlemen. Okay, you guys see that there? That's the first triangle. And when you cross multiply, we'll see what we get. So if we cross multiply, we get C. Sine what? 43 becomes 186 sine 71. I can divide both sides by sine 43, right? Aren't you going to get C 186 sine of 71 degrees? Everything over sine of what? 43. And then, just to say to you guys, I really don't need this information anymore. Okay? Because we're going to use that little fact I gave you guys here. So I'm going to delete that. And C. What is C going to be, ladies and gentlemen? All right? Punch that in your calculator. You cross multiplied. Right? You solve for C. So in that TI now, let's clear that out. 186 sine of what? 71 degrees divided by sine of what? 43 degrees. What do you guys end up with? What's that little c going to be? Let's go to the nearest tenths, okay? So we're going to go to the tenths here. So c is going to be approximately, that's little c. What is that? 257 point what? 9. 257.9. And there's your little C, ladies and gentlemen. That's for your first what? Triangle. You have two. All right, you guys okay with that? And now the second one, you say, how do I get the second one? Exactly the same way. We're going to get little c here. Okay, I'll erase that. And again, highlight 23 degrees, little c. Remember, we were using the original ratio here. Sine 43 over 186, which is sine 23 over what? Little c. And again, that's the second triangle, okay? That's a situation where the ambiguous case gives you two. Right? Solving for little c. Let's look at that detail again, right? You get c sine 43 is 186 sine 23. Divide both sides by that little c. You get 186 sine 23 degrees divided by sine of 43 degrees. We're going to get that little c. All right, in case you guys want to see the notes there. Okay, you guys ready for the calculator work? Ready for the TI? Okay. Now it's 186 sine of what? 23 divided by sine of what? 43. And what do you guys get? Go into the nearest tenths here. 106.6. Good. So that's going to be the remaining little c here, 106.6. And so, sure enough, we do have what? Two solutions. Okay. So this is the details behind how many what? This is the two solution. So the ambiguous case, right? Go back here. This is either going to have one triangle solution or two triangle solutions, or what's the last case? None. Good. Good. Now let me show you the none. Are you guys ready? I showed you the one triangle solution, the two triangle solutions, and now the none solution. You go, whoa, there's a none. Well, not the none. Did you guys see the none too? Is it any good? It was okay? Did you see The Exorcist? The new one. Which one? I don't think it was that good, was it? You think the Nun 2 was better? Yeah. Really? Okay. Made a bad choice. I want to go see The Exorcist, and it's not a very good story. It's not a good story. Anyway. Oh, is that right? I don't like those movies that have a lot of blood. Okay, I'm going to share with you guys the last one for the ambiguous case, SSA. And, you know, they could give you a triangle that looks like this, I guess. You know, I didn't do it, but I'll put that little line, 42. This is 123. And this is, let's say this is 122. Let's say this is 70. Okay. A, B, and this is C. So let me share with you guys why this is side angle, right? they gave you two adjacent sides. This is the side. And you could read it counterclockwise or clockwise. Side, what? Angle. Here's the angle, and here's the opposite side, okay? So we're going to start with that fact. Sine 42 degrees divided by what? 70, right? You say, why do we start with this? Because they're both known. And then we have no choice again. We have to go with little b and 122. So you say, why? Because there's one known quantity. The little b is known. So we can say sine little b over 122. Okay, you guys okay with that? That's law of sines, right? Okay, is that true? Right, you guys see it? Should I give you the guys the colors? 42 over 70. B, little b. Okay, let's cross multiply. Cross multiply. Could you guys solve for sine b? Yes. Divide both sides now by 70. Okay. Now, just like before, ladies and gentlemen, I'm going to say to you guys, find that numerical value. Right? Use your TI to find this number. So you have 122 sine of what? 42, right? Divided by the number 70 in your calculator. See what you guys end up with. What do you get? Right? What is sine B approximated to the thousandths? 1.16 what? 6. Okay. Now, what's the problem with this, ladies and gentlemen? I'm going to say to you guys, this answer is problematic. Okay? You have a problem here. This could never happen. Does anybody know why sine could never be bigger than 1? What did we just get through sharing with you guys? Sine of any angle is between -1 and what? +1. So it could never happen. Right? You go back to the sine curve. You go, what do you mean? Right? If you go back to the sine curve like we did here, there are no angles where what? Where sine is bigger than 1 here. This is what's called the range, if you guys remember those things here. The range of sine is between -1 and 1, so you can't be bigger than 1 for a sine curve. It's outside that range. We even wrote that down here. So because of that, you might say, well, what if I forget that on a test and then I try to do what? Right? You say, what if I forget and I write down that B is the inverse sine of 1.166 because I want to go through and find little b, I want to find B, angle B, in your calculator. What do you think your calculator is going to tell you? It's going to give you an error. You're right, because the calculator knows, hey, you can't have that. So when you try it, you go, oh, error. Right? You guys see that error there? All right. So that's why there's an error. Okay. So in other words, this means there's what again? No what? Solution. There is no solution. Your triangle can't take on that shape. So you could never have a triangle, ladies and gentlemen. Never, 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 that has these dimensions. Okay? There is no such triangle here. So this is the last situation for the ambiguous case, being no what? No solution. Okay, you guys okay with that? Okay. So let me give you guys another example of some of these things here. Okay, because they might even say to you guys, I want to find, they're going to do something like this. They're going to say little a equals what? 30. Little c equals what? 40. Angle A is, what's angle A? 37 degrees. And they'll say use law of sines to solve the what? The triangle. Okay, so obviously here, I'm going to say to you guys, you might say, Mr. Judge, where is the triangle at? They didn't even give me a triangle. You know what they're going to make you do? Sketch your own. Exactly. Huh? Right. You might say, how do I even begin to do that? Well, here's what I want to remind you guys. First of all, law of sines don't sketch a right triangle. Is that right? You can't have a right triangle. You don't have, law of sines doesn't apply to a right triangle. It applies to a what? Oblique triangle. So you sketch a what? Oblique what? Triangle. So I'm going to do something here. I'm going to focus on what they gave me with an angle. You guys see how they gave me what? A 37 degree angle? So what I would try to do if this were me is I'm going to draw a triangle here where that 37 degree angle, right? Remember now, if you have, the question is going to be if it's oblique, do you have an acute triangle? Or do you have an obtuse triangle? So I'm going to write that down. I'm just going to think about it that way. It can either be acute or obtuse. We don't know. Right? What's an acute triangle? Where all three angles are less than 90. What's an obtuse triangle? When you have what? One angle that's greater than 90 degrees. So because they gave me a 37 degrees, which is less than 90, I just drew sort of an acute triangle situation. Okay? So I'm going to put this angle anywhere I want. Where do you guys want to put that angle? Anywhere. I might put it here, 37 degrees. Okay? And they're calling that angle A. Is that true? So I'm going to name this vertice what? A. So if you have to sketch it yourself because they gave you words, then what do you guys do? Sketch it yourself. Now, what vertice is B? Doesn't matter. Doesn't matter which one is B. You can go clockwise or counterclockwise. Does not matter. So you can say, hey, this would be angle B, and this would be angle what? C. So it does not matter what you name the vertices. Okay, you guys okay with that? Now, what else did they give you? Well, they gave us what? Little a, which is 30. So you said, oh, they gave me this, and they gave me what? This. So I got, this is 30, because isn't that little a? They have to be opposite. You guys see my point? Easy peasy. What else did they give you guys? Oh, they gave me little c. Well, where do I put that 40 then? Over here. Isn't that where little c is? So, ladies and gentlemen, angle B right here, and that's going to be side B. That has to be B. So what kind of situation did they give us? Remember, what is this? What case is this? Is it side, angle, side? Do you guys know what I mean? What did they just give us? Let's see if we can read what they gave us. They gave us two what? Two adjacent sides, side, and then they give us a what? Angle. Side, what? Angle. So what do I have to know once they give me this? Side, angle, ladies and gentlemen, this is known as the what? Ambiguous what? Case. So I have to be aware of that, right? Side, angle, ambiguous case. So they may give you words, ladies and gentlemen, and if they do, all righty. We can solve these triangles. So remember how you guys start. How do you guys start the process? We're going to say what? Sine 37 degrees over 30. Okay, equals, has to be what? Sine C now over what? Over 40. Because I have to have two known, have a known angle and the opposite side. Those are the A's in this case. And then I have to have the situation where one is known. In this case, 40 is known, but we don't know C. So take a look at this. We're going to use law of what? Sines here. And we had to sketch our own triangle. Okay. Cross what? Multiply. Have you guys seen this before? You should. Don't wait till the night before. 40 sine 37 degrees becomes what? 30 sine C. So we get to divide both sides now by what? By 30. Sine C becomes 40 times sine of what? 37 degrees over 30. So numerically, we want to find out what this is. Okay? Use your calculator here. Clear, clear. Okay. 40 sine of 37, is that what it was? Divided by what? 30. And what do we get? Is that bigger than 1? No. So guess what? We're going to have two solutions. Is that right? So it'll be 0.802. So, okay, that's what I wrote down. This is what we just found. How do I get angle C now? Do you guys know how I get C? Yes. C will be inverse sine of 0.802. Use the inverse sine. Let's see what C is approximately now. Second inverse sine of what? 0.802. And what do we got? 53 degrees. Is that true? Okay, what I'm going to call this, ladies and gentlemen, though, you know what I'm going to call this? This is going to be C what? 1. Good. I'm in the ambiguous case. There could be two solutions. So how do I get C2 now? The second solution will always be the supplement of the what? Of the first solution. So you take 180 minus 53, okay? (180 minus what? 53 becomes what? 127 degrees. So I'll do all that now, ladies and gentlemen, because, you know, let's get the two angles now, just in case. There could be two solutions. We don't know. So what I'll do is I go back now here. Let's go back here. We're going to get this triangle here. C1 is 53 degrees. Okay. Could you guys tell me, how do I get the missing angle? How do I get B? Right, we're going to take 180 minus 37 minus 53. Okay, so let's get out the calculator. 180 minus what? Minus 53? 90 degrees. Are you serious? That's odd. That's weird. Let me double check. And this is from the book. I didn't even make it up. You said, Mr. Judge, I thought they weren't going to give us this. All right, let's write down what this means. $90, what is this? 40, 30, 37, and what? 53 degrees. Isn't that weird? This is from the book. Number 18. They gave us a right triangle? You said, Mr. Judge, I thought they're not going to do that. Well, that's a little weird. That's odd, ladies and gentlemen. So let me ask you guys this question then. How do I get little b? Because this is the definition of a what? Right triangle. Odd. Okay, well, it's from our book. So what do you guys think that, how do we get this? Anybody remember the right triangle information? How do you solve a right triangle? You got to know sine, cosine, tangent. Is that right? Isn't that the hypotenuse? So pick an angle. I don't know what color. No. So if I said to you, what is sine of 37 degrees? What's the definition? Opposite over what? Hypotenuse. Okay, so then if I create that ratio and cross multiply, what do we get? This is from your book. B, sine what? 37 is 1 times 30, or what is B? 30 divided by what? Sine 37. What is my B going to be approximately? It's weird, but... Oh. Sorry. So those people at home couldn't see. I'm not sure what happened to our... For our Ecamm Live. So in other words, I showed people here, we got this missing angle to be 90, which makes this a right triangle. I'm not supposed to really see that, but okay. I'll say, okay, Arthur, that's what you did. Now we're going to try to find that little b. So we use the definition of sine 37. Sine 37, if you guys remember, opposite over hypotenuse. This is what we got 30 in b. It's the definition of sine. Solving for b. Now we get to look at the TI. $30 divided by sine of what? 37. What do you guys end up with? Go to the nearest tenth, I guess. For sides, I like to go to the nearest tenths. What's that going to be? 49.8. So for angles, I like whole numbers. Sides, I like what? Tenths. So we got little b, 49.8. Okay, so that's going to be up here. And ladies and gentlemen, yeah, we solved for the triangle there. So you might say, well, what about this situation here where C2 is 127? Is there a second triangle? Well, I don't know. Let's see. Is there a second triangle here? So what angle did we get? Was it C, 127? Wasn't this the second? C? C2, 127. Okay, let's see if that makes any sense. How do I get angle B? 180 minus 127 minus what? 37. So let's find this angle. See if there's a second triangle. 180 minus what? 127 minus what? 37. Is that 16 degrees? Okay, that looks like this is 16 degrees. Okay, so what do you think, ladies and gentlemen? Does that make any sense? Does it make sense that there'll be a 16-degree angle? It's not negative. Good. Good job. Now, Fine. How do we use law of sines? Use the red. Sine 37, the two known here from the original. Now what do we have to do? Sine of what? 16 over little b, because we're trying to solve for this triangle. So double check. This is the red. Angle and opposite side. And then here's my what? Angle and opposite side here. Okay. Cross what? Cross multiply. Okay, so take a look for you guys at home writing all this down, or even in the classroom, write that stuff down. We're almost done there, so ladies and gentlemen, let's finish this off here. Okay, little b, sine 37 degrees becomes 30. Okay, sine 16 degrees. Divide both sides by sine 37. And little b is 30. Sine 16 over sine what? 37. Okay? Go back here, take a look. Right, is that true? Did we do everything okay? All right, ladies and gentlemen, let's try this out. Here we go. 30 sine what? 16 divided by sine of 30 what? 7. And I like going to the tens. What'd you guys get for little b? Little b is 13.7, and I guess that was orange. So as you guys can see, we did have two triangles where one of them is actually a right triangle. And we did use law of sines here to get that. So two solutions.
So, anytime there's a 90-degree angle, we can't solve it like on the basis of triangle.
What's that?